Hello, good morning. Am I audible?
Yes, sir.
Okay. So, I want to one more time show you the screen. Can you see my screen? Can you
Yes,
see?
sir.
Yes, sir.
Okay. So this is how I want to one more time show you how the conductors are placed. This is a three-phase winding structure, three-phase two-pole structure. You can see how the conductors are placed. This is dot conductors on the top, A phase, and after 180-degree electrical degrees as well as mechanical degrees, because this is a two-pole structure, as well as mechanical degrees, you are seeing the cross placement of the cross conductors here. This is the dot conductor, this is the cross conductor, and therefore this is the coil axis. This is the coil axis. So with that thing in mind, B and C coil axis will be 120-degree shifted. So that's why B coil axis is here. B coil axis is here, and C coil axis is another 120-degree shifted. That means it will be uh, where is the C? This is coil axis. No, this is the this is what they are defining as dot position of the dot conductors. This B is position of the dot conductors here. B dash is position of the cross conductors of the B phase, and C is the position uh, of the dot conductors of C phase, and C dash is position of the cross conductors of the C phase. The conductors are placed in such a way that B conductor axis is leading actually with the A conductor A coil axis. The A coil axis is here. You can see that it is here. This is here. So the B coil axis will be here, will be somewhere here, 120-degree shifted here, and the C coil axis will be another 120-degree shifted and will be somewhere here, C coil axis. So this is how the conductors are placed. So coils are placed here, conductors are placed here, coil axis is orthogonal to it. This is the orthogonal to it. So you just remember this picture, and this 60 degree is the coil span. This is the coil span. It is having a span of 60 degrees. And coil pitch is 180 degree. That is why the cross conductors are 180 degree apart. So you know that already. I'm just reminding. And then I wanted to show you this picture that I was referring to yesterday. This is the picture. If you take the A coil, this is A coil dot, A coil cross, you can see that every time a current passes through a conductor, it is like it creates uh, an MMF in the air gap of step number of turns in that slot into the current. Current is the instantaneous current. So every time it passes, a current passes, a step. Step is the step implies the magnitude of the MMF, and for how long it is can be considered to be north pole and how long it can be considered to be south pole. So the total MMF is essentially divided into two parts, Ni uh, plus Ni and minus Ni. You can note that here there are two conductors. So actually then it is 2 N into I, 2 into N into I. Okay. So divided by into two parts, one for the positive part and one in the negative part. And this is how the distribution would be when you sum up all the MMFs, because they are distributed in space. The coils are distributed in space. So the MMFs that they create is also distributed in space. And by giving it a proper, by giving, by this distribution, you can see that it is more or less approaching a sine wave in space. At every instant there is a current. For every instant current, because the coils are distributed in space, coils means phase A coils. Phase A coils are distributed in space. Their MMFs will also be distributed in space. Its magnitude is proportional to the current passing through that coil. All the coils are taking same current. They are essentially connected in series, going around and coming in, going around and coming in. That means this coil cross is related to this portion dot. This coil cross is related to this portion dot. So this way they are connected, all connected in series. However, they are producing an MMF which is better, because otherwise if you had done all concentrated winding, you would have created an MMF that shape is rectangular. So it would have more space harmonics. Here this is what is having less space harmonics. And you can even do better if you even adjust the number of turns. If you adjust the number of turns, you not only distribute but adjust the number of turns, you can also make it more or less approaching a sine wave. You can understand that. In the final portion, the MMF increment should be very less. So accordingly, your number of turns, it should be very less compared to the other number of turns in that particular slot. So you vary the number of turns in the slot. This is the slot, and you can make it very close to a sinusoidal MMF. So then after that, we all think that the MMF produced by the coil is a sinusoid. Okay. After all that, the coil axis remains here. The combined effect of the coil axis is here. You see the coil axis is here. That is not changing. Every slot has a different coil axis, but they are symmetric. So therefore, the after summing, we will get a coil axis at the center. You can see that it is the coil axis at the center. It is not the coil axis for the leftmost coil. It is not the coil axis for the leftmost coil, but it is the coil axis of this coil. So because it is centered, it's symmetric. This is the middle one, is the symmetric. It has two left and two right. So this coil axis, it will be the actual resultant coil axis. That means MMF will be aligned to that coil, that axis. The MMF created, MMF, flux density, all will be aligned to that axis. Now we have a sinusoidal distribution, and if you vary the current, this will jump around. The magnitude of the sine wave will jump around. That means as if the sine waves, the magnitude will be, you can vary by varying the current. This is for one phase. Now if similarly the B phase and for C phase, whose coil axes are 120 degree shifted. Okay, and individually you are passing current onto this coil A as well as coil B and coil C. And as you know, these currents are not in time phase synchronized. They are in time, the currents have a shift in time. Okay, so this time shift in the coils, that means in the A coil, it may be cos omega t. In the B coil, it can be cos omega t minus 120 degree. And the C coil, it may be cos omega t plus 120 degree. So if you put this pattern, so you just try to imagine in each phase it is jumping around. That this jump around has a time shift. Jumping around has a time shift. And the combined effect of the MMF, the combined effect of these three phase currents producing MMF in the space, in the periphery of the air gap, is what? It is then as if one unique sine wave is moving around. It's moving around. That is what is called rotating magnetic field. A sine wave means a north pole and a south pole. A flux, a rotating magnet. We call it a rotating magnet. North pole and south pole will be moving around. This is happening in anywhere there is a three-phase winding, and anywhere you are able to create a current of that nature, which are time shifted. Anywhere you have constructed a three-phase winding, two things are done. One is construction. By construction, you are putting coils in that particular manner: phase A coil, phase B coil, phase C coils. Okay, being consciously creating their axis 120 degree apart in space, and along with that, you are supplying current or supplying voltage, or I better to say current, because the MMF is related to current. You are creating current in the coil, which are 120 degree time shifted. You have done it in the stator, and in this rotor, if you do that, there is no reason why rotor will not create such an MMF. Rotor will also create such an MMF, because you are able to produce an induced voltage in the rotor, and that induced voltage in the rotor is creating current, and the induced voltage are phase shifted, and therefore the currents are also phase shifted. So three phase currents are created. Okay, three phase currents are created in the rotor, and rotor is also producing a magnetic field, and that magnetic field is rotating with respect to whom? With respect to the rotor. With respect. Now, rotor may be having some speed. So the resultant magnetic field, the magnetic field created by the rotor has a speed with respect to rotor that is proportional to the frequency of the voltage that is created inside the rotor, or the current frequency of the current that is inside the rotor. But with respect to the stator, if somebody observes from the stator, what does he see? First, he sees that the rotor itself is moving, and with respect to the rotor, the magnetic field is moving. So he or she will see that the magnetic field is now rotating at a speed which is same as the speed of the stator magnetic field. There is no difference. So they combine again the stator and rotor magnetic field. Stator and rotor magnetic field, not correct word. Magnetic field created by the stator coil current and magnetic field created by the rotor coil current. Again, let us pause and think. Rotor coil current is not at the same frequency as the stator coil current, but the magnetic field created by the rotor coil current is synchronized with the magnetic field created by the stator coil current. This you understand or not? Any one of you don't, if you don't understand, please feel free. Please tell me, do you understand it clearly? Do you understand? I hope you understand it. Otherwise, please speak. Shourodeep, do you understand? Hello, am I not audible?
Yes, sir, you're audible.
You're audible.
Okay, so you are getting it? Hemasri and Hemasri, do you get it?
Yes, sir.
Okay, so so that is how the these two magnetic fields are there. One is caused by the stator current, one is caused by the rotor current. Stator current magnetic field is created by simply imposing a voltage source. Simply imposing a voltage source of frequency of your choice. Let us call it omega s, omega suffix s, right? And the rotor, you don't choose the frequency. It automatically builds up the frequency that is necessary. So it will build up the frequency that will be the difference between the stator frequency, that means stator supply frequency, and the rotor speed, that one, rotor speed. So that difference will be the frequency of the voltage created in the rotor coil. And rotor coil, we have shorted it. Since we have shorted it, the rotor coil is going through, is carrying some current, limited by however small the resistance and inductance of that coil is. Very small. So you indirectly, I am saying that it is creating a very small voltage. It is creating smaller and smaller voltage as it speeds up. Because this induced EMF, as we know, is also a function of the difference in the frequency. As we know, this is it also depends upon the difference in the frequency. So this way, magnetic field wise, they are synchronized. Magnetic field wise, stator and rotor magnetic fields are synchronized. So what happens is they sum. You can sum. Their axes may be slightly different. It is not that their axes are exactly aligned, but doesn't matter. Two things can be summed if their frequency is the same. If rotational frequency is the same, and they're rotating with respect to the stator at the same frequency. That is the frequency of the stator supply, omega s. So they are rotating at that speed. So they sum up, and that summation we call it the air gap. air gap flux. Air gap flux is the summation of the magnetic field created by the stator current plus the summation of the magnetic field created by the stator current and the rotor current. That is what is known as the air gap flux. And this air gap flux is responsible for induction of the voltage in the coil. Voltage induced in a coil depends upon the total amount of flux linked by the coil, and the total amount of flux is coming out of two sources, one from the stator current and one from the rotor current. So all of them together is producing what we consider as air gap magnetic field, and that air gap magnetic field is producing voltage in stator coil as well as in the rotor coil. Only thing is the air gap magnetic field will appear to be rotating at omega s speed with respect to the stator coil and at a speed of omega s minus omega r, omega rotor with respect to the rotor coil, right? So let's do a small derivation and let me quickly show you that. I quickly bring a new quantity called synchronous speed.
Sir.
Yes.
So one question is like the torque expression in Fitzgerald it is given as like pi by 2 p by 2 whole square and then phi. How is the derivation like? I tried to find but it is not given.
Sir, that was derived in class.
That was derived in class, and that if you see, no, that I have already covered that flux magnitude that I am telling, that is because otherwise they are giving in terms of another variable, the average flux, etc. So if you look at the Fitzgerald-Kingsley definition, if you take the equation number, I will tell you the equation number 2 is matching with our equation. So this is more original equation. Later they are changing variables and bringing out new equations. Let me see that page.
Sir, I had one doubt in that expression, in that formula. Like when TKB sir derived that formula, he derived it for a two-pole machine, and then it said if there are several poles, then we just multiply that expression with the pole pair p by 2. Sir, like how is that? I couldn't really understand that.
Are you right? Something means, can you minimize your MS Teams window that is popped out?
I'm not yet writing. I'm trying to open one writing pad first. Let me open and then tell you. One minute. I'm trying to open my writing pad. So let it open. It's taking time to open. So I am asked two questions. Let me tell you that if you look at, I don't know what is the question, what is the equation number. If you look at the equation number 3.83, it actually gives you the same expression that I am telling you. Here the torque expression in Fitzgerald-Kingsley's book is giving in terms of BSR. B is flux density SR, and then they are saying it is pi dl by 2 into p by 2. Right? Now, this pi dl by 2 is corresponds to the area, and that if you put it properly with flux expression, this covers up that flux expression. So I am writing in terms of flux, and they in this book, this is in this place it is written in terms of flux density. So this dl etc. comes, and pi by 2 also comes in that because of that reason. Okay, so if you want me to link it, I will link it in another day. I will just so that these two are the same thing. And some of you are asking why it is p by 2. Now think that a machine has 4 poles. So why it is not opening? 1 minute. This is part of the problem. I should have kept it opened earlier. Okay. Okay. Maybe you will get the idea. Because I'm doing a 4-pole machine here. I'll do a 4-pole machine and I will show you how it is coming. Let me draw it and then I will tell you why. So so if you see, I'm sorry, I have to restart the machine. This is not working. Please stay. I will be restarting the machine.